Alright, so this is how I've been requesting you guys to send me your questions. You just take a screenshot of it, just like Tarina did, and I can respond to you via email or video. And in this case, I'd rather do the video because that way you can all benefit from each other's questions. So Tarina asked me 2 questions in this email, and there's several others which I strongly urge you to take a look at in week 6. So, okay, so the first question that she came up with is one of the questions you're going to hit when you get to about the 70th topic, around there. And if you notice in this case, it says, suppose that the heights of adult women in the United States are normally distributed with a mean of 63.5 inches and a standard deviation of 2.4 inches. Jennifer is taller than 85% of the U.S. population of U.S. women. They want to know how tall she is. So what I'm going to bring your attention to here is a couple of things about the normal distribution, which, again, some of you have already started with the Chevy Chev and the normal distribution questions, but I want to make a connection for you here. And I'm also going to show you how to use Excel to solve for this question. So I'm going to begin with, once you get to these questions where you're doing inference, we're looking for the Z-score formula, which in essence looks like this. Okay, and in this case, they didn't give you the Z. They gave you that Jennifer is at the 85th percentile, basically. Right, because they said 85%. So we're going to convert that to a decimal, 0.85, and we're going to use Excel to make to compute our Z-score quicker. What they're asking us in the question is, we're trying to find X. What we're given is the mu, which is the mean, right? And they're giving us the standard deviation. Alright, so in our case, when we use Excel, you are simply going to go open up Excel. A blank page is all you need. It's like the Target commercial, you have to just wait for it to open. Alright, and so we're going to go into one of the empty cells. I'm just going to go into equals, and then I'm going to type in the letter N. And then I'm going to scroll all the way down. You see here where it says norm S inverse without any decimals. Double click on that. And we're going to put in 0.85 and hit enter. There's your Z-score. So this is the Z-score. And again, what did I do? You simply use equals. You have to put the equal to sign first. N, get the drop down menu once you do that, and then you're searching for norm S inverse, and then you put in the area. Now what I need you to understand is that the Z-score, which in this case we computed it to be 1.036433, if I'm looking at this diagram, here's your normal distribution. We know that the mean is 60. Let me go back here, close this. The mean is 63.5 inches. As I go up deviations, and I believe the standard deviation was 2.4 inches, I'm adding 2.4 as I go to the next Z-score. So if I have 63.5, I'm going to add 2.4, and this becomes 65.9 for the Z equal to 1. At this point, Z is equal to 0, by the way. Alright, at Z equal to 2, we have 65.9 plus 2.4 again. That gives us 68.3. Here's Z equal to 2. And my third deviation, I'm adding 2.4 yet again, and I'm getting 70.7. This is where Z equals 3. Going backwards, I'm going to start at 63.5 again, and I'm going to subtract 2.4 to get z equal to -1, where this is 61.1. At z equal to -2, I'm at 58.7. This is z equal to -2. And lastly, if I take away 2.4 again, I'm at 56.3, and that's z equal to -3. Now, if you remember, between the -1 and +1 standard deviations, we hold 68% of the data. Looking at between -2 and +2 standard deviations, we have 95% of the data. And lastly, between -3 and +3 standard deviations, we're at 99.7% of the data. So as I'm looking at this, I'm thinking, okay, if up to here, if I were to cut this this diagram in half, here's 50%. At this point, I'm at 84%. I'm adding a little bit more, so that z-score is sitting somewhere in here. Since z is equal to 1, our z was 1.036433, so it's just slightly a little bit more than R1. So that's 1.036433. The area that's sitting above this is 15%. The area that is behind this is 85%. So when you read a question like this is how you would interpret it. Now, to find our actual values, this is what we do know. We do not know x. We're searching for x. We know that mu is 63.5. We know the standard deviation is 2.4, and we know that now this is equal to 1.036433. So what we will do is we will multiply these out. So we end up with x minus 63.5 equals 1.0336433 times 2.4. And the last step, we're going to add 63.5 to this value. Alright, and so this will cancel here, leaving you x equals. So, using a calculator, you will take 1.03433 times 2.4, and you're going to add 63.5 to get 65.987. They want you to round this to, I believe, 3 decimals, or to the first decimal place, which would make that a 0. And so your x value is actually 66.0. And this is the cutoff for that 85th. So in other words, if I'm searching for this equivalent number, my equivalent number for this z-score is 66.0.